Assalamualaikum warahmatullahi wabarakatuh. Good morning. Hello everyone. My name is Mira Ayu Rahmawati and you can call me Miss Mira. Today I want to explain about object physics with material, work, and energy. Okay. Before starting today's lesson, let's pray together. Praying begin. Pray over. Okay. Today we can listen about work and energy with me, Miss Mira Ayu Rahmawati. The first basic concept of work. Work is done only when a constant force applied on an object causes the object to move in the same direction as the force applied. What is considered as work done in physics? Number one, you push a heavy shopping trailer for 20 meters. And number two, you lift your school bags upward by 2 meters. Next, what is not considered as work done in physics? Number one, you push against a wall. Number two, jumping continuously on the same spot. And number three, holding a chair and walking around the classroom. Next, formula of work done. Formula of work is W, same as V. Formula of work done is W, same as V cross S. W is work done, V is constant force, and S is distance moved in the direction of force. Example, you are helping to push your mother using shopping cart with a force of 50 Newton for 200 meters. What is amount of work done? Work done is W equal V cross S, same as 50 cross 200, 200, same as 10,000 joule or 10 kilojoule. Example number 2, Jack put on his backpack of weight 120 Newton. He then started running up on level ground for 100 meters before he starting to climb up a ladder up a height of 10 meters. How much work was done? From basic point of view, no work is done back at level ground. Reason, lift is perpendicular to movement. Work is done on back only when Jack climbs up the ladder. So work done is W equal F cross S, same as 120 cross 6. So W same as 1200 joule. Okay, next about the concept of energy. Energy is the capacity to do work. Form of energy: chemical energy, electrical energy, sound energy, nuclear energy, light energy, heat energy, kinetic energy, and potential energy. Okay, kinetic energy. Kinetic energy, a form of energy that a body in motion process. A body at rest will it process any kinetic energy. Example, bullet shot out from pistol, helicopter flying at 120 km per hour. Formula of kinetic energy. Kinetic energy is same as uh, 1/2 cross massa cross velocity square. So kinetic energy is same as 1/2 cross m cross v square. Okay, please watching simulation about kinetic energy.
Objects in motion possesses energy called kinetic energy. Let us now see how a moving object can use its kinetic energy to do work. Here, we have a trolley attached to a suspended pan of weights on one side and a rigid support on the other with a thread. A wood block is placed at a fixed distance from the trolley on the side with the pan weights. Release the trolley from the rigid support. The trolley moves forward and hits the wooden block, hence displacing the block. This means work is done on the block by the trolley as the block has gained energy. Note the displacement corresponding to the weight on the pan. Now, repeat the experiment with higher weight on the pan. We can see that the trolley moves with higher speed and the block is displaced more. Here, the trolley acquired higher kinetic energy by attaining higher speed and the work done by it increased. We can hence conclude that moving objects can do work, and the kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it acquire that velocity.
Okay, guys. Uh, that's that's about simulation kinetic energy. And next, example about kinetic energy. A motorcycle acceleration at 2 meter per second square from rest for 5 seconds. Find the kinetic energy of motorcycle after 5 seconds. Mass of motorcycle is 200 kilogram. Velocity of motorcycle after 5 seconds is 10 meter per second, and kinetic energy of motorcycle at 10 meter per second is 1/2 cross 200 cross 10 square. So, kinetic energy of motorcycle at 10 meter per second is 10 kilojoule. Okay, next, potential energy. Potential energy is the energy processed by an object as a result of its position or condition. Examples: spring wind, stretcher, or compressor. It is condition. And number two, when a child will lifted from ground a distance of 1 meter. This is position. Formula of potential energy: M cross G cross H. Okay, this is a simulation about potential energy and kinetic energy.
Imagine you have a ball which you throw upwards. As the ball travels upwards, we say that it has kinetic energy. Kinetic energy is a form of energy possessed by a body due to its motion. Therefore, anything that moves has kinetic energy, such as a car traveling on the road and a plane flying in the sky. Even you possess kinetic energy when you walk or run. In fact, the faster a body moves, the greater its kinetic energy. Therefore, when you run, you have more kinetic energy than when you walk. When a body stops, there's no more kinetic energy. When you come to a stop, or when the car stops moving, kinetic energy becomes zero. If we now raise the ball to a certain height and release it, what happens? It starts falling downwards, right? It starts from a position of rest and then gains speed when you let it go. In other words, it starts with zero kinetic energy and then gains some kinetic energy. Where does this kinetic energy come from? This energy, which is stored in the ball, is called potential energy. Potential energy is a form of energy stored in a body due to its position. Let's have a closer look. Here, the position is the ball's height from the ground. When you release it, the potential energy converts to kinetic energy. In fact, the higher the ball, the larger its potential energy. That is why if we raise the ball to a greater distance from the ground and release it, it will hit the ground harder. Let's look at another example. Look at the slingshot. It has stored energy with which it can throw the bird up to a certain distance. Based on its position in the slingshot, we can say the bird has potential energy. As soon as it's released from the slingshot, it gains kinetic energy. And because of kinetic energy, it is able to apply force on the little houses to break them down. Time for an exercise. Who has the greatest potential energy? Bubbles has the most potential energy because she is at the top. We know that potential energy increases with the increase in the distance of a body from the ground. Let's summarize. Potential energy is the energy of a body due to its position. Kinetic energy, on the other hand, is the energy of a body due to its motion. Potential energy mostly depends on the distance of the body from the ground. Kinetic energy depends on its speed.
Okay. Next example, you read a set of books of mass 3 kilograms per 2 meter. What is the potential energy given by the books? Take G same as 10 meter per second square. GPA same as mgh. So GPA same as 60 joule. Find the work done by you to leave the book. Work done W equal F cross T. F is M cross T. So work done is 60 joule. Okay, this is not same as GPA. Okay. Next, this is correct assessment. Assessment test. Number one, to stick a pill that is 10 centimeter long, the pill is hit by a load of 5 tons from a height of 1 meter above. If you average resistance force at the place of planting the long pill is 100 Kelvin, then the number of sticks so that the pill evolves with the ground is blank blank blank. Okay, solution by the problem is like this. S sum as 10 centimeter, M sum as 5 tons, or 5,000 kilogram, H sum as 1 meter, and F sum as so answer W sum as N dot energy potential or potential energy. So N same as 20 times. Okay, next is students worksheet. You can writing your name, your absence, and your class. Okay, tools and experimental materials. Number one, nail, wonder, hammer, wood, or scrapboard. Okay, this is work step. Pay attention to the demonstration that teacher make. One, analysis and determine what variables will be present in the table of observation from the experiment. Number two, analysis and determine which variable are fixed independent variable and variable to the experiment. Number three, make a table of observation from the experiment. Number four, experiment 5 times with different N and S variation. And the last, analysis the table of experiment result and draw conclusion from the experiments. Okay, everyone. If you have a question, please to raise hand or writing in comment. Okay, I think nothing question. So thank you so much for today. I hope you'll better again for next week. And I end this lesson. Thank you so much. And wassalamualaikum warahmatullahi wabarakatuh.